Hello friends, this is Snigdha Kakkad and this is my channel AccelerateAICareers. Today we'll be solving LeetCode 41, first missing positive. It is a hard level problem. It has been asked in Amazon, Microsoft and Google interviews. Now why is it hard? It is not hard per se. It has varied number of solutions. One of those solutions has time complexity O of n log, which is relatively very easy to code. Then there is another solution which is O(n) time complexity but with O(n) space complexity, which is a little tough when compared to prior solution but still easier to manage. And then there is a third one which has linear time complexity O(n) and constant space complexity O(1). So that is the solution which has been asked in this problem and hence the hard status. What's first missing positive basically? The first positive integer is 1, as we all know. Now first missing positive integer, so you have been given an array nums, for example here 1, 2, 0, and you have to find the first positive integer which is missing in this array. So if you look here in this array, 0 is present, then 1 is present, and 2 is present, then what's missing? So by default, 3 is missing here because you have all prior to 3, that is 0, 1, 2 are there. So the numbers in the range 1, 2 which are positive integers are already present. And then the next following integer which is missing is 3. Let's look at another example. So we are given another array 3, 4, -1, 1. So if you see, first of all, we can sort this array. So the sorting itself takes O(n) log n. That is your first solution. So if you sort this array, it will become -1, 1, 3, 4. And if you follow first missing positive rule, so you have 1, then you have 3, and then you have 4. So what's missing? 2. So basically the least positive integer which is missing from this array is 2, in place of which -1 is present. Now following the same solution of O(n) log n, that is sorting, say suppose we are given this array num 7, 8, 9, 11, 12. Here also the array is already sorted. So if we look, the first missing positive integer, so do you see 1 is not present here? So of course 1 is the smallest positive integer that is missing. So I hope at least the question is clear to you. And then how the first solution, which is sorting the array and then checking from the first digit in the array which positive integer is missing, that is O(n) log n time complexity. Now for the second approach, let's take a step back. Let's take an example. Our nums array, say for example it is 1, 2, 4. So what would be your first missing positive integer here? So 1 is there, then 2 is there, but 3 is not there. So your first missing integer here is 3. So, but say suppose the nums array is 1, 2, 3. In that case, what would be your first missing integer? You have 1, you have 2, you have 3. Then by default, the missing integer would be 3 plus 1, that is 4. Okay. We can establish two observations from here. First observation would be that your missing positive integer, first missing positive integer, n will always be between 1 to whatever your array length is, length of the array nums, plus 1. So when 3 was missing, at that time, you checked from n equal to 1 to the length of array is 3. So length of array 3 plus 1, 4. So you checked from 1 to 4 and you checked 3 is missing. When 4 was missing, then also you checked from 1 to length of array which is 3 plus 1 which is 4. So this rule will apply anytime. So you actually don't need to sort the array. You basically need to check whether 1 to length of whatever the array is plus 1, what particular positive integer is missing, and the first one which is missing is your answer. So that comprises your this solution. But how come the space complexity is O(n)? That comes into view when you save all the digits present in your array to a hash set. And then you check from 1 to the length of nums plus 1. You check 1 is present here in the hash set, then 2 is present in the hash set, then 3 is present in the hash set. So basically, since you're using a hash set, that's why your space complexity turns out to be O of n. And your time complexity will be O(n) because you are checking from 1 to length of nums plus 1, which is length of the array. So basically your time complexity would also be O of n and space complexity would also be O of n. And you don't need to sort the array. So I hope that solution is also clear. Now we'll move to the next solution. Now what if I don't want to use the additional space, that is the additional hash set, and I want to do it within O1 time complexity? We can talk about the third solution, which is O(n) time complexity and O1 space complexity. So to do that, say suppose I have an example 3, minus 2, 6, 3. So suppose I have my nums array as this. Now I'm not using hash set, so how would I track which integer has already occurred from this 1 to length of nums array plus 1 and which integer has not occurred? So to do that, I will be using my array itself. But do you see that my array has negative integers here? But do negative integers value for me? Because I am just tracking first missing positive. So negative integers are of no value to me. So I might even cross out them or I might even replace them with 0. So say suppose I choose to replace them with 0. Then my array would be 3, 0, 6, 3. Now how do I track which positive integer has occurred from 1 to length of nums plus 1 in this particular nums array? Now to track which digit has occurred and which digit has not occurred, we will make them negative. So for example, if I look at I equals to 0, that is the 0th index here, I can see the digit 3. So 3 digit, that is from 1 to length of array plus 1, 3 digit has occurred at which index? So 3 digit should occur at n minus 1 index. So basically, this 3 digit should occur at n minus 1, that is second index. Because your n will be in the range of 1 to length of nums plus 1. So essentially, index would be 1 subtracted from the n value. So that's how I'm computing it. So the 3 digits should occur at second index. So second index, you have 6 here. So you will basically make 6 as negative. That is, multiply it with 1 to show that the second index digit, which is supposed to be 3, has occurred. Which that is, it is present in array somewhere. Now let's go to n equal to 0. Now n equal to 0 is not in range 1 to length of nums plus 1. So it doesn't matter where it occurs, but let's check. So to check 0 minus 1, that is minus 1th index, which is out of bounds. So it is out of bounds, we can ignore it. Now let's go to n equal to minus 6. So now you have already made it negative. So you cannot check for minus 6 minus 1. You have to check for absolute value of minus 6 minus 1, which is 5. That is 5th index. Now 5th index is again out of bounds. 5th index is out of bounds. So you cannot check that, skip it. Now let's go to next value. Next value is 3. So 3 minus 1, 2, that is second index. Second index is already negative, which you have made negative. So hence it has already occurred. That means you know that 3 is there somewhere in the array. So if you see, you are basically running the O of n loop 3 times. So first time you replace all the negatives occurring in the array with 0. That is your first change. And you loop through 1 to n. The second loop which you run is you modify the array based on 1 to length of nums plus 1 and checking which digit has occurred, which digit has not occurred. And third, you make them negatives, right? So even though you are going through O of 3 of n, but still the time complexity will remain O of n. I hope that is clear. And space complexity is O of 1 since you are not utilizing some additional space. Now there is one edge case which we have not handled so far because we didn't have to face it with this example. But let's modify this example to explain you that edge case. So say suppose your array is not 3 minus 2, 6, 3. But there is another value which is 2. So you have a 5-digit array. And first of all, you replace any negatives with 0. And then you check for the digits present. So same way as we have done before, you will check for n equal to 3. So index would be 3 minus 1, that is 2. So second index, you will make it negative. Same way, you will check for n equal to 0, that is minus 1th index, which is out of bounds, so no change. Then n equal to minus 6, so absolute value of minus 6, which is 6 minus 1, 5. So 5th index, Fifth index would be 0, 1, 2, 3, 4. Again out of bounds, so no change. Now n equal to 3. Again, you have already done it. It would be second index, and second index is already negative. So leave it as is. Now n equal to 2. N equal to 2 means 2 minus 1, that is 1th index, and 1th index is 0. So 0 cannot be made negative. So that is your edge case. You cannot make 0 negative. How will you get to know 2 has occurred in the array? So to get to know, you have to not replace by 0 or by 1, but you need to replace any negative occurrence in the array with minus of length of array plus 1, which is your maximum positive value. So since this would be out of bounds, so there is no chance that it will occur in the array, and minus length of nums plus 1, if you keep it here, so that would help you turn it negative just in case this case happens. So now if minus length of nums plus 1, that is length of array would be 4 plus 1 minus 5. So you will replace by minus 5 here, and in case the 2 n equal to 2, then 2 minus 1 first index, so you would turn that value to negative. I hope that clarifies. So to handle that edge case, any negative should not be replaced by 0, but they should be replaced by minus length of nums plus 1. Now why can't we replace by 1? So if we replace by 1, any negatives if we replace by 1, in that case you are changing the structure of your array, and you will not be able to find the right first missing positive, because 1 is also one of those first positives. So you cannot replace with 0, you cannot replace with 1, you have to replace with minus length of nums plus 1. I hope that clarifies this edge case, and you know how to get the time complexity as O(n) and space complexity as O(1) now. Now let's get coding the solution. Now to code our solution in O(n) time complexity and O(1) space complexity, we will run through the entire array 3 times. So the first time we run through the entire array would be for I in range length of nums. And what we will do? We will check if any value in nums is negative. If any value, say suppose nums I is negative, that is less than 0, then we set it to 0. Why? Because we have to find first missing positive, not first missing negative. So the negative values are of no consequence to us. So the first action we do is set anything which is negative in the array, looping through the array, and set it to 0. Now second time we loop through the array again, and then we first take the absolute of the current value. So we do absolute of nums I. Because the value could be negative in an array, like in this example, you can see the value is minus 2, it is negative. So you first have to take the absolute of nums I, just in case any value is negative, and you run the entire loop. After you have taken the absolute, you check whether this value is in bounds. So if this value basically is greater than equal to 1 and less than equal to length of nums. If that is the case, that it is in bounds, not out of bounds, in that case you would check for n-1 index, that is val -1 index. So then you check if nums val -1. So like when I was explaining, I told you that if the value is n, say 3, then you check for 3-1 index, that is second index. This is the same thing. So if the value is absolute of nums I and it is in bounds, then you check for val -1th index. So val -1th index value we are checking, and we check whether this value is greater than 0 or equal to 0. So if it is greater than 0, that means this value is positive. So then you have to set it to negative. So how do you set the value to negative? You multiply it by -1. So, multiply by -1. Now, the other condition could be that this value of the array is equal to 0. Now, in the case that it is equal to 0, I told you that it could be an edge case when this value is already set to 0. In that case, you set it to the extreme value, which is minus of length of nums plus 1. So this will be our edge case. So we'll check if this value is equal to 0. If that is the case, in that case we will multiply it by -1 and then length of nums plus 1. So just in case any value turns out to be 0, we set it to the max value -1 length of nums plus 1. Now the third time we run through the loop is again for I in range, and we check for values from 1 to length of nums plus 1. So we check whether that value is present in the array or not. So how do we check? We check if nums I minus 1. So like I mentioned that if the value is val, then the index would be val minus 1th index, and you will check nums val minus 1. Same thing we are doing. For I in range from 1 to length nums plus 1, we check if nums I minus 1 is greater than equal to 0. If it is greater than or equal to 0, return I. And if this value is not present, say suppose we checked and all the values we have checked are all present from 1 to length nums plus 1, all values are present. In that case, it's again an edge case, and you would return length of nums plus 1. So the first loop which we ran was setting up any negative value which is there in the array to 0, because you don't need negative values. The second loop which you run is you first take the absolute of the current number, absolute of nums I, and you then check whether that value is inbounds. If that value is inbounds, then you check for that value minus 1th index, and if it is positive, you set it to negative. And otherwise, if this value is 0, then you set it to the edge case, that is minus of length of nums plus 1. Now the third time when you run across the loop is you run in the range 1 to length of nums plus 1, and you check whether that particular value is there in your array or not. So you check whether nums of I minus 1 is greater than equal to 0 or not. So usually if a particular value is present, in that case corresponding to that minus 1th index value should be negative. Or if it is not negative, that means that value is missing. So if nums I minus 1 is greater than equal to 0, that means that value is missing, and you return that in value, return I. If all the values are negative, that means all values are present till length of nums. In that case, you return length of nums plus 1. I hope that clarifies. Let's run it and see. So the solution is accepted. Let's submit. So you can see how much accurate the solution is. I know this is a difficult one. When I started coding it, it was not easy for me as well to understand all the 3 loops and why I'm implementing one condition, why I'm implementing the other condition. So if you are also stuck, let me know which point is not clear, and I can explain the solution in an understandable and easy way with more examples again. Don't hesitate to ask questions. Thank you.